Now let's start solving add two binary strings. So the question is saying that given two binary strings S1 and S2 consisting of only zeros and ones, find the resultant string after adding the two binary strings. Okay, there is one note given. It says the input strings may contain leading zeros, but the output string should not have any leading zeros. So you need to take care of that in your solution. So this question is very straightforward. It just asks you to add up two strings. Okay, and these two strings are going to be binary strings. So that means the zeros and ones that is has as a data type of string or character, you need to convert it to an integer and you need to deal it with zeros and ones as a decimal number. Then you need to add it up, and then you need to add it up in the form that you are dealing with binary digits. Okay, so we're gonna see how we are how we will achieve that. First of all, let's try to learn a little from these test cases. So as you can see, in this test case, you have these two strings, 1101, and the another string, the S2, is 111. Once these two strings are added, we have this resultant string, and this is what we need to give as the answer. All right. Similarly with this one, this has a little variation, which was specifically mentioned as a note that your input can have leading zeros, but make sure that your output doesn't. Coming on to how we can achieve this addition, let's just practically do it once. Taking this example up, 1101 and adding 111 to it. Okay, if you try to add binary numbers, then what happens? Okay, let's say you have 1 plus 1. Well, normally if you do it in the decimal mathematics, you would have 2, but in binary you only have either 0 or 1 to represent things. So what do? What would be the representation of 2 then? Well, for that, you must do this 2 modulo 2. What do you get? You get 0. That means 0 is what should be placed here as a part of your answer. Then, actually, if you try to divide it, then what do you have? You have 1. 1 is going to be the carry number. 1, 0 is the representation of 2, and this part is going to be a carry. This part is going to be the part of your answer. Going ahead with the same algorithm, let's try to add these things. You have 1 as a carry, which is going to be added to these both. These are 1s and 0. So again, you have 2, 1 situation. You would have answer as 2. I would place my 0 here. I would place my 0 here, and 1 would go here. Now here is some new situation occurring. In decimal, if you want to count it, this can go up to 3. But what do? Let's do 3 modulo 2. Now what you'll get 1. And if you try to divide it, means this symbol, okay, you again would get 1. That means here the part of the result is going to be attached as 1. The carry that would go, that also will be 1. All right. Now for this time, if you want to add these both things, you know what does it give? It gives 1, 0. And why you are not making it at the carry? Because both of the strings length is finished. Okay. So in this, you got this answer, just like this one, 1, 0, 1, 0, 0. Okay. Now you know how to perform additions in this, in the binary strings. Very clear. How are we approaching this? Well, for that, let's take a look at the code, and it will be very clear how we are taking up the variables and how we are running the loops. Okay. Let's now discuss the code for this problem. I have S1 and S2, my two strings. What initially I'm doing is I am calling this function trim leading zeros. Okay, the function is written here. What is the work of this function? This trims out if there are any leading zeros in your string. This will get rid of it for you. Okay, so I've called that upon S1 and then S2. And now these two variables, my S1 string and my S2 string, are free of any leading zeros, which means that now I can start adding these two. Okay, but before that, the way I have made my logic, in that my S1 is always considered, if not equal to S2, so it is going to be bigger. Okay, so here that is what I'm doing. I've kept the track of both of the lengths. Okay, n is the length of S1 and m is the length of S2. I'm comparing that if n is smaller, then I would swap both of the S1 and S2 and the values nm. So what I'll have is always my S1 is going to be bigger in length. Okay. So once that is done, now I'm going to begin up my logic. For that, I've taken one index j, which is going to be beginning from the end of S2. Okay, the string 2 I have, it is going to be beginning from the end of it. And then I'm taking these two variables. First of all, carry, which is going to help me add, and the result, in which I'm going to store the result. Okay, this is a empty list initially. So I have used this loop. This loop is used to iterate reverse in the array. Okay, so I'm going to be using this loop on S1. You can see I've put n here because I am considering that this loop would be looping up S1. And who's taking care of S2? The variable j is taking care of S2's iteration. Okay, so what I'm doing here, I have taken my S1's ith value, considering initially this last one. I've taken that one, I've converted that one into integer so that I can use it with my logic. So I have kept that in bit 1. Then we have this variable bit sum. What it does is it stores the summation of carry and this bit value. Okay, once these two things are added up, we see that whether S2 is left to add or not, because S2 is remember, S2 could be a smaller string which can get exhausted. So after this, after we are done with adding carry and bit 1, we will check that if my j is still remaining, j is greater than or equal to 0, that means there are few more, there are more integers, or you can say binary values available in my S2. Then I would add, I would have that in bit2 variable, and then I would add that to bit sum as well. Okay, and along with that, I need to keep maintain my j. Every step that I take in this direction, right to left, I am going to do j minus 1, j equals j minus 1. All right, once that is done, then I have to take care of the answers. How do we take care of that? I would see that if my bit sum is a bigger value, I will be taking modulo by 2, which I would store here in bit, and then I have to decide the carry, okay, which would be bit sum divided by 2. We have already seen why we are doing this. And once we are done with that one, what I'll do is I will append this result in my result array. I will append this bit and in the form of a string, make sure of that, in my result list. So once my execution of this loop is done, then I'd come outside and I'd check that if I have carry present, that means I have 1 as my carry, that would also be appended to my result. Now we are traveling from right to left direction to solve our question, but when we are calculating the result and when we are storing values in that, that was in this direction, left to right. So because this is the complete reverse, so once it's done, then I would just simply reverse my result list and I would convert it to a string. That is what this join function is doing, and then it would be returned as an answer. Okay, so quite simple. I hope you have understood the approach here, and let's discuss the time complexity for it. Well, we are not going to be iterating any more than order of n plus m in this one, n being the length of bigger array, m being the length of a smaller array, and I am taking a little space, that is to store my result, correct? So if you consider that, then order of n is going to be your space complexity for it. Okay, so let's move ahead to executing this code. All right, so here's the code. Let's try to compile and run it. All right, you can see it is giving us the desired output as well. Then once I'm done with it, let's try to submit that. All right, so it has passed all of the test cases that we have. So I hope now you have understood this code and approach clearly. If you already had a little idea about binary, then this question is just a little implementation of that. So again, as I say, that if you have any confusion, take up a test case, try to run that yourself, and you would have complete hold of your code, what each and every line is doing. Thank you for watching this video so far. And if you have liked the approach, do tell that to me in the comments and like the video. Thanks.